bytecode program starting at $CF80, which reads the contents of $0. $sign is basically representing hexadecimal. So 0100 adds it to the content 0101, stores the result 0100, and repeats from the beginning until the result in 0100 is 0. You may use any other opcodes found in this exam as well. BN $26 for looping and WGAI $3 to stop the program. Int should be 12 bytes. Okay, so here we had to design a code. Initially, it reads this content, so it means we had to load an accumulator with this number. Okay, so initially read this one and then add this one, then we have to add an accumulator and then store this one. We have to store accumulator, and it repeats from the beginning until the result in this one is 0. So we had to use BNE. So BNE is basically if branch not equal to 0, it's going to keep on uh, going back until it becomes 0. It only exits after it becomes 0. So you may use that, and um, looping and WAI to stop your programs. This is like wait forever, right? So in order to do this, we had to know we need to know some stuff. Right? So here visible. Here we go. So here are some instructions. 6HHC11 instruction. Here we have load accumulator A, that is LDA. Okay, that we can use here. In order to load this one, we have to use LDA. We can use LDA, and LDA takes 2 bytes. Okay, that also we have takes 2 bytes, and then here they also ask us to store result into this, so we had to use STAA, that store accumulator. Okay, that's STAA, and we had to do we had to add as well. So add accumulator, and that also takes 2 bytes. So each of them take 2 bytes, and also you have to know the opcodes. The opcode for the loading process is B6, and opcode for the adding process, opcode for the store accumulator is $B7. Okay, based on that, I can write the code right now. So let's see. So the code basically comes like $sign B6 for the load accumulator. For load, just B6 code, and then accumulator A is 8, only store 8 bit at a time, so we are twice. It takes 8 bit at a time. 0101 we store like we load like 01, which reads 0100. So it as I have to put 0100 here. This is LDAA. We are loading 0100. Now to loading alone is taking 2 bytes. Each of them is byte. Byte is basically 8 bits. So each of the digits, this is in hexadecimal, each of the digits is 4 bits. So 4 plus 4, 8 bits. So this one taking 1 bit, 1 byte, 2 byte, 3 byte, and the opcode take 1 byte. So totally we have 3 bytes for this. Okay. Then they ask us to add it to the content of 0101. So for that we have to just add. Now to add this, This is the opcode BB, and add it to the content 0101. So I use 0101 right here. That is the 101. Here also, this one is a byte, bytes, totally byte. And then store the result in 0100. The storing is right here SAA, and that opcode is B7. So B7, and then we are storing 0100. So result, uh, store the result 0100. Yeah, store 0. So this one is storing process STAA, and we are storing 0 Here, if you look at this one byte, 2 byte, 3 byte, get 3 bytes. So totally 9 bytes used. And also here they say that you may use and repeats from the beginning until the result in 0100 is 0. So to repeat the process until it becomes 0, we have to use something called BNE. BNE is basically branch not equal to 0. So it's gonna keep on branching until equal to 0. When it's equal to 0, it's gonna exit the branch. So to do that, it's already mentioned, the output is already mentioned, that is 20. Put that one right here. And there's one more thing you have to put for the BNE, that is F5. Okay, this one is NE, and here we are just repeating. So there's nothing we are doing here. We're just giving this command that it's gonna only exist when it equal to 0, otherwise it's gonna keep on branching. For this one, we take bytes. Okay, totally we have 3 bytes, 3 bytes, 3 bytes, 9 bytes, and 2 bytes, 11. And the last one is WA, that's wait forever. For this one, the opcode is already provided here, that's 3E WAI. It only takes 1 byte, doesn't have anything else. So totally we are deriving 12 byte, and this is the code. Okay, the opcodes takes 1 byte, and whatever the things you are trying to do, that's take one, like based on what you're doing. If you're using accumulator A, 1 byte for each percentage. Okay, you can only represent 8 at a time. So that's how you do this kind of problem. I hope you guys found this video helpful. Thanks for watching. Don't forget to subscribe my channel. See you guys on my next video.